So the next question which we have in hand is a very conceptual problem. We are given that the vapor pressure of ethanol and methanol are 44.5 and 88.7 millimeters of mercury, and an ideal solution is formed by mixing 60 grams of ethanol and 40 grams of methanol at the same temperature. We need to calculate the total vapor pressure of the solution in the first part and the mole fraction of methanol in vapor state in the second part. If we assume the vapor pressure of ethanol to be equal to P ethanol naught and assume the mole fraction of ethanol to be equal to X ethanol, and if we assume the vapor pressure of methanol to be P naught methanol and the mole fraction of methanol in the solution to be equal to X methanol, then the total pressure can be found out by the summation of P naught ethanol into X ethanol and P naught methanol into X methanol. Here this is the vapor pressure of ethanol which is given to be equal to 44.5. This is the vapor pressure of methanol which is given to be 88.7. This is the mole fraction of ethanol in the solution state. Mind it is in the solution state and not in the vapor state. And this is the mole fraction of methanol again in the solution state. Mind you, most of the students commit mistakes by confusing this thing with the mole fraction of ethanol and mole fraction of methanol in the vapor state. But these are in the solution state. So first of all, we have to find the mole fraction in the solution state. Then we'll try to find out in the vapor state. So for the first part, since the weights of methanol and ethanol are given, so we can find out the number of moles of each of them. For ethanol, the number of moles is equal to the weight which is given to be equal to 60 grams divided by its molecular weight which is 46 grams to get the moles of ethanol as 1.304, and in the similar way moles of methanol can be calculated as weight which is 40 divided by its molecular weight which is 32. This comes out as 1.25. Hence the mole fraction of ethanol is 1.304 divided by 1.304 plus 1.25. This comes out as 0.51, and hence the total mole fraction is 1. So mole fraction of methanol is 1 minus 0.51, which is 0.49. These mole fractions are the mole fractions of ethanol and methanol in the liquid state. So now the total pressure of the solution can be found out by vapor pressure of ethanol into its mole fraction plus vapor pressure of methanol into its mole fraction. On solving, the total pressure comes out to be equal to 66.13 millimeter of mercury. Now in the second part, this is the answer of the first part of the total pressure or the total vapor pressure of the solution. In the second part, we need to find the mole fraction of methanol in the vapor state. For this, very obviously, the mole fraction of methanol in the vapor state is equal to the vapor pressure of methanol upon the total pressure into the mole fraction of methanol in the liquid state. We have found the vapor pressure. This is the vapor pressure of methanol, which is given to be equal to 88.7 into the mole fraction of methanol, which was 0.49, divided by the total pressure, which we found out to be equal to 66.13. This is the mole fraction of methanol in the vapor state. This is equal to the vapor pressure of methanol divided by the total pressure into the mole fraction of methanol in the liquid state. And hence, on solving this, we get the value of X methanol in the vapor state to be equal to 0.66, and hence our final answers are mole fraction of methanol in the vapor state is 0.66 and the total final pressure is 66.13 millimeters of mercury.